All right, let's get started. Brazil. All right, let's get started. My friends from Brazil, that's great. Brazil. All right, thank you for being here today. All right, let's get going. Let's get started. I got a lot of friends in Brazil. I've done a lot of work with some of them, but let's keep going. So hopefully more people will join us. Anyhow, just to start this presentation, all the materials that you see today, the source code is in the GitHub repo. I'll share the link with you. The in the presentation is being recorded. I'll forward that via email. But let's get started. So I'm glad for everyone to us today. But let's start the conversation by just thinking about what happens in a data engineering project, right? What do we do when we start in the process of the discovery process of analyzing what data is available for us? And how do we do, what tools do we use to be able to execute this project? So after today's conversation presentation, you'll be able to sort of understand, to have a sort of a process-oriented mindset to be able to attack data engineering projects and get exposure to some of the tools that are available out there for us to sort of manage and execute a project like this. So welcome to today's presentation from raw data to analytics, when we are exploring the modern data layer architecture. First of all, my name is Oscar Garcia. My expertise are around application architect, cloud, web, and data technologies. I love to share what I learn. And I'm also the author of the book, Data Engineering Process Fundamentals. A lot of the stuff you see here today are basically based on that book. You have a lot of, you have a GitHub repo and articles that I've written about this. So today's focus is mostly on the data lake, data warehouse, and how we can use those tools. But there's a lot other material around that we're gonna briefly cover today. But our main focus is just to look at the data lakes and data warehouses. All right, so let's start with just an overview, right? What is data engineering? So data engineering is really a process to follow a series of steps. So if we execute them properly and understand the problem statement in the scope of work, we can actually come up with a design and architecture that's going to deliver this solution for us. Okay, and this includes the ability to provide an analytical layer for tools and reporting tools. The topics today are focused on data lake and data warehouse. We're going to briefly talk about discovery and data analysis, definitely cover design and infrastructure planning, and the details of how to build a data pipeline that we can actually run on using data lakes and a data warehouse. So at the end of this presentation, you'll be able to have an overall idea of everything that we're talking about. So all the code that you see today is actually on that GitHub repo that you see. You can actually quickly just copy and paste just to make it easier. And basically, you can just go ahead and look at all the source code, all the data examples that we have, and you can actually start, if you can start and follow the project. That gives us more the ability to basically grow this even more. Okay, so let's continue. All right, so let's start with the concept of operational data. If you are a database developer, a DBA, if you like to explore data, you probably have worked with relational databases like SQL Server, Oracle, SQLite. Perhaps you worked on NoSQL or document databases that are basically JSON, based on JSON documents like MongoDB, Firebase, and so on. These databases, these systems basically are designed for us to use as for operational data. And what that really means is the ability to build applications and have those applications do transactions on this databases, right? So like create a customer record, to perhaps create some kind of order, inventory request, anything of that nature that is actually mostly interact by applications, whether it's mobile apps or web applications. So some of the features for this, of course, is that they support transactions, right? They have a relational data structure, and they could be SQL or document structure like JSON documents. If you're not familiar with JSON documents, basically is your NoSQL technology that enables us to basically create applications in a sort of not schema binding approach. Okay. So, but they're really just designed for that, for transactions, for small queries, for us to build applications, right? But they're really not good for reporting system, for running large queries, and for building centralized big data systems, right? So, and that's one of the problems that we see all the time in industries, right? Where we run in SQL Server and things of that nature, and everybody's using the transactional operational databases, and they're trying to build reports and do some batch updates and massive amount of work that actually just create a lot of blocking, a lot of data contention and problems to a database. So that the thinking is, so if we can now use the operational data for that, what do we do? What do we do next? So we have to move that data, right? The answer is that we have to move that data away from the operational database and actually start thinking more of on an analytical architecture. And how do we do? So the first step is to sort of understand what a data lake is, right? And you will hear, you usually hear something like analytical data staging. And what does that mean, right? In a nutshell, a data lake is an optimized storage system for big data scenarios. But that really means, that fancy title is just really the ability to store data, large amounts of data in raw format without any transfer. So usually what happens is when we do, for example, a NoSQL database, we have large JSON documents, right? Or if we do like SQL Server and we export data, we probably create CSV files, right? And there could be huge, right? And those that raw data it mirrors what's on that system. Whatever the system of record is, that raw data just has the structure for that system. So just to have the ability to be able to move or migrate that data into a data lake is very useful, for the reasons that we can store the raw data there without any transformation. That immediately is a great advantage, that we don't have to build sophisticated pipelines. We can only drop those files there and actually start using them, right? The cost of the storage is a lot lower, right? So they're using basically the core storage technology there is blob storage, right? So, and there are different tiers for storing. You know, you have hot, you have cold data, you have archive data. There's different tiers of what that data is, and so the cost will be less, which is important when we're building solutions, whether it's web, database, what have you. We have to be mindful of the cost, the operational costs associated to that solution, right? So even though this data that we actually move into a data lake is really not designed for data analysis, you can actually query the data, and I'll show you the approach to do that. You can actually query the data, but it's really not structured well in analysis, right? There's got to be an additional step for us to be able to do that. But it gives us the advantage that from a data warehouse standpoint, we can use the data lake and use those files as external tables, right? And external tables, basically, if you think of a SQL table, it's just really a table out there that is not optimized, and the structure is just whatever that raw structure of that data looks like. So how do we do if we cannot really use the data lake with raw data like that? Well, what is the whole purpose of moving that data to a data lake? Well, the idea is that the staging area in the data lake is our gators, our analytical platform, right? So, and that's where we're talking about when we introduce a data warehouse. So basically, it's the data warehouse. It is a centralized storage systems, right? That stores data that has been migrated and integrated from multiple sources. So now we talked about we can have SQL Server data, have NoSQL database data, JSON, XMLs, CSVs, but in the data lake. But ultimately, we want to transform this data. We want to optimize this data and move it into an analytical platform, right? So and definitely at this point now, you are actually, since you are using a system that has also storage, the cost of a data warehouse is higher than a data lake. So you have to come up with the strategies to be able to say what to store in data lake, what to store in the data warehouse, how to archive the data, and so on, right? So that's one of the things that we need to kind of start thinking about. But the idea of the data warehouse is that stores the historical data in a relational table in optimized schema format. So what that means really is in the raw data from an unstructured or a structured data for that particular system into an optimized centralized schema that we can actually query for analytical purposes, right? The data warehouse provides SQL support to query that data and can integrate with external resources with different formats like CSV, Parquet files, and so on. So this system really, data warehouse is really designed big data scenario. So you can have data in real time, you can have data in batch processes, you can have massive amounts of data, and the architecture for data warehouse is optimized to provide a lot of parallelism to be able to query this information and be able to give us that platform that enables the analytical process. So what's important, though, to be able to come up with this approach and understand what we need to do, one of the stepping stones of this is the data analysis. In the example that we are seeing today, that we are reviewing today, we're basically doing an analysis of a data set that we are importing from an external system, right? But it's important for us to understand what the data looks like. So the data analysis or data discovery process is very important. With that, we need to identify what the data looks like, what the structure looks like, what are the sources, the frequency of the updates of the data. And this helps us in a way to actually scope the design and architecture of our data warehouse solution, right? So basically, we need to sort of download the data, run some experiments on it, and come up with some observations of the data. And this we can do SQL, using Python, Jupyter notebooks, many tools that are available out there. But what's important is the actual process to be able to analyze the data, because with that, we come up with all the requirements that are going to translate into our data warehouse, into our data lake and data warehouse. Once you visit the GitHub repo, you'll go to a folder. There's a discovery folder in there. That's where you have all this source code there. So you have the Jupyter notebook files where you can actually experiment with some of that data. But right now we are just kind of refreshing a little bit about the discovery phase, just to make sure that we understand that that's what enables the entire architecture of this project, right? So and also another or a step to sort of refresh, right? To a refresher for us, and I call it refresh because I have presentations, completely separate presentations on this, right? On the discovery phase, there's a presentation out there. If you go to the YouTube channel, you'll be able to see that presentation. And there's also design and planning. So what do we mean by design and planning? So once we understand the requirements once we scope of work and we kind of start thinking about how we're going to build out this data platform solution, we sort of need to kind of start doing design and planning for that. And what that really means is, what tools are we building? I mean, what technologies are we using and what solution we are building, right? So for example, we need to build a data lake. We need to provision a data warehouse. We need to provision a VM for our code to run if you're doing a code-centric approach. And how are those solutions going to run? Are we going to be using Docker? Are we going to be using maybe just some cloud service? So all those things are very important during the design and planning phase. So here, what you see here that I'm highlighting is that in our case, we're building out a data lake, we're building out a data warehouse and a VM engine. And for our approach is we're going to use Terraform. So if you're not familiar with Terraform, it's just really a way to build cloud infrastructure. So think of Terraform like configuration files that you can code and basically implement. Like, for example, I want to build a data lake. I want to build a data warehouse and VM with these configurations. And we can actually use GitHub and use CI/CD pipelines or GitHub Actions to be able to actually deploy code. So deploy infrastructure. So it's completely different than deploying the code, right? Deploying the code is something where the code, the Python code is deployed. Here we're talking about deploying infrastructure. So deploying those commands to be able to say, build me a data lake, build me a data warehouse, and so on. This is very fundamentally important in the process of data engineering. So, and this is really what you probably want to do. And read a little bit about that so you get familiar with that. But so it's really that we're able to build our data warehouse and data lake. All right. So now we sort of understand the how do we build the data lake, and we sort of understand the so how do we use this, right? What do we use the data lake and the data warehouse? So the data lake now is your storage, right? But the data has to get there somehow, right? So we need to start building data pipelines. So that's when you start hearing conversations about data pipeline, orchestration, and what does that mean, right? So to simplify the term, a data pipeline is really just a workflow that executes tasks or steps, and that code can be executed using Docker containers for isolation, right? If you're not familiar with Docker containers, is the ability, provides you with the ability to create a bubble and isolate the dependent for your code to execute, right? So that's the actual code, and it's really a workflow, but something has to run this workflow, right? Something has to coordinate the steps, and that's what we call orchestration. So orchestration is really the execution, the scheduling, managing, and monitor of the pipeline, right? So this is what you need to sort of understand, that you need the orchestration to be able to understand that your processes are running properly at the right time, and there's really data being processed, that something is not failing, right? So, and for this, we can actually use a code-centric pipeline using languages like Python, right, to be able to do that. Or we can use a low-code approach and use tools like Azure Data Factory, Google Data Prep, right? And these are sort of low-code, no-code tools that enables us to kind of design and orchestrate a data pipeline that says, connect to this database, read this data, move it to a data lake, and so on, right? But the important thing here is that you need those tools to be able to manage the deployments of these pipelines, monitor their processes, and do the scheduling of it. So if you look at this diagram, right, it just gives us the angle. It says basically that we have CSV files that can go two ways, and actually more than two ways. Of course, data can go also in real time for other type of integration. But we can process the file through Azure Cloud with Data Factory or Google Data Prep, and we can move them if we do a code-centric pipeline, we can use Python, and then we need a VM to process the CSV, or we use factory to process the CSV. But the purpose is that whatever the pipeline looks like, we're moving that data from the source, from a CSV file, from a JSON file, into the data lake with no transformation. And by the way, let me also add that you could do transformation if you want into the data lake, but you don't really have to. And it really depends on what you're trying to achieve. One thing that I observe is I prefer to move raw data into the data lake because I want to get the data as is from the system of record. And then I handle transformation in a subsequent stage, and I isolate what's on the data lake for raw data to what's really something that we already transformed. And then that gives you traceability, gives you lineage, the ability to say, I got the data to this point like this, I know it's untouched, and now I'm forming it and applying it. So, all right, so welcome other attendees. Thank you for joining us today. All right, so let's continue. So, all right. Okay, so now we understand now that the pipeline is going to help us move from system of records. It's going to help us move the system of records into our data lake, and that's what we call staging, right? So how do we make it get to the data warehouse? What are the next steps for us to be able to get it there? Right, so that's where we need to work on our design and architecture phases of the data warehouse, right? So now that we have the data warehouse, we need to work on creating the schema model for our data warehouse. Understand the technology stack that we're going to be using, and by that I mean, are we using a lot of more Python, or can we as well, right? So that really depends on the team structure, on your expertise, and so on. And also be mindful that what you could do in a data warehouse as far as batch processing is concerned will be a lot faster than using any type of Python batch processing. So Python pipelines are more for, in a way, for small batches and transactional data. If you want the power of SQL, then you move that job into a SQL. Anyway, so in the implementation phase, so we talk about the design phase, right? We're talking about the schema model, the technology stack, and so on. But how do we implement this? What are we actually executing, right? So in the implementation phase, we actually focus on converting a conceptual data model into a functional system. Okay, so what does that mean, right? So when we go through the design phase, we actually start looking at the data, the raw data, and we start identifying the models. And the models are, for example, the dimensions, right? So for example, in this case, you'll see it more in detail. We're talking about a subway system. So basically, the dimensions for that system will be things like the station, right? The station for where the train stops, right? That's important to track. So that's a dimension, right? So it's important to sort of identify these dimensions and what are the facts that we're tracking, right? So a fact table basically gives us a transaction. So for example, a transaction in this case will be a train stopping at a station X at a particular time, and the number of commuters in that train. That will be a transaction. So it's important to sort of on this and be able to design and implement now the data, right? The solution. So when we do the implementation now, that's when we start doing data cleansing, data transformation, data integration, scheduling, data modeling, right? So we are decomposing basically the raw data, and we're breaking it apart into conceptual data models with dimensions and fact tables. So it's very important that we understand. What you see here in this diagram, right, is that by taking this approach, we can actually, from the data lake, which is our staging environment, we can actually create our facts and dimension tables and enhance that data with metadata. And metadata really is maybe some data that's relevant to your business that is necessary for you to enhance the information that you're getting from the data sources, right? And from there, you can create your dashboard, or you can specialize the data into data marts, right? For example, stations and demographics, right? How many commuters, and what are the demographics of those commuters, right? So that's sort of very important for us to understand. All right. So, okay. So, and once we get to the data warehouse, we can do the data analysis, right? We'll take a look at that more in detail. So we're gonna jump on to basically, we're gonna stop it here for the presentation. We're gonna move on to the code so we can actually see what we're talking about. Okay. Let me just make sure that you can see the screen. Let me know. You should be I should be presenting Visual Studio Code in front of you. Can you see that? Yes. Okay. All right. So this project that I have loaded here, Visual Studio Code, is really is that GitHub repo, right? So that if you visit that link that I added to the chat, you will see all the folders like discovery, cloud infrastructure, which is design planning, orchestration, data warehouse, analysis, data streaming, also for real-time integrations, right? So there's a lot of material here, a lot of stuff that you can take a look, and I'm just kind of giving an overview specifically to data lakes and in the data warehouse. So this is the code, and before I start playing with it really quick, I'm just gonna switch back to the console. So we're using Google Cloud for this, but remember, the concepts are applicable to anything. If you're looking at Google Cloud, basically what you see here is a data lake, right? And this really is, think of it as a directory that has a bunch of files. And you can see that we have a bunch of compressed files here for a particular day range. And basically what happens here is that we're saying in our data lake that we have this raw data, but how do we consume this raw data, right? So this is just a compressed gzip file, and how do we read this in a way that is useful? Of course, we can use Python. The data got here through Python, and I'll show you that in a minute. And we can use tools like that to do it. But the moment it's in the data lake, if we remember our architecture, we want to be able to use the data lake strictly from our data warehouse, right? So this is sort of the architecture that we have here. So what we can do at this point is, how do we read these files? So the way that works with data warehouses, so this is the data lake cloud. I'm going to take you to the data warehouse on Google Cloud as well. So here what we have is that we have a BigQuery instance running here, and basically here we have a couple of data sets, and basically think of data sets as your databases, right? And where you store your tables, your views, your stored procedures, and things of that nature. But from the standpoint of the world of the data warehouse focus, you can build. Well, we talked about it, right? We can build external tables to look into a data warehouse. So here, basically, we can look at this external table here. And if you remember, that's the folder. We call this folder turnstile, right? So this is the turnstile folder. Let me blow it up a little bit. I hope you can see that. Right, so this is the turnstile, and we have all these files here. And look at the file names, right? Look at the pattern of the file name. That's important because this is how we can enable this process, right? So what we do here is we can go to this external table that we define, right, with some field names, and we can create a very loose, very relaxed schema, because we don't know everything really what's going on. So we just kind of, based on what we can infer, we can kind of create a schema to read that. But the point, the details here is that the way we connect to this is that we say, hey, configurable to load everything that is in this data lake path. So data lake path that we have here, we're saying, hey, use this pattern, csv.gc. So imagine if I had other file types, right? So imagine if I had, for example, let's say we have contracts, or we have customers, or we have something else, right? So we can create a pattern that says contract star.csv, customer star.csv, and we can create external tables that are actually external customers, external contracts, and so on. But the idea here now is that we can kind of come here and just basically write our SQL, right? We can actually say, it's like, hey, you know, and if you want to just be playing with Gemini here embedded into the studio, but you can actually say, hey, and this is really just a quick way to kind of say, hey, just query this, right? And it's kind of interesting that they are all these cloud companies, technology companies are embedding AI in everything, and it's just basically for you this really query, right, which is kind of easy to write, but just to show you the capabilities. And you can just go here, and what this is basically doing is saying, hey, from this data warehouse, from the data warehouse itself, loading that external table through the data lake, select the data that is in there, right? And it just is returning all the data that we see. So this enables us now to sort of understand data looks like from the standpoint of the data warehouse, and be able to looking at our conceptual models and understand it, right? And that is from the data warehouse perspective, right? But that's not very realistic at this point. I just took you guys forward into the data warehouse, but in reality, you do this through the discovery process, right? Through the discovery process, you go, you query the data, you analyze it, you kind of see it, and then you start thinking about building your external tables and all those things. So if you look at the discovery folder, you'll have a discovery Jupyter notebook file where you can actually execute all these queries, and you can analyze the data and make observations, able to gather your requirements based on that data. So I won't go into more detail of that, but this is the idea, that you look at your discovery files and you query the data, you analyze it, and you basically do that. So, but going back to data lake, data warehouse. So now I'll show you from a concentric perspective, right? So we're playing with a data lake here, and we can just write Python code to be able to query this. So I could just come here and using Google Cloud APIs and Python, I can just go and set up my pandas, set up my project information, and basically, hey, show me all the files that are on the data lake, right? So this just goes and through the API goes and it reads the file, and I can just read data from the data lake here and analyze it, right? I can say, hey, show me this data, let me look at the data, and so on. Of course, so what this shows us is that we can interact from the data warehouse into the data lake, and we can also interact from code into the data lake and do some of the stuff that we need to do, right? So this is basically all this work that is doing. So okay, so how does the data get there, right? Because we had some files there. We saw that we have some files there. So what we got to do is we got to run the data pipeline, right? And the data pipeline, really what that is, and when you go to step 3, which is orchestration, you'll see flows. You see a folder called, let me see if I can blow this up. You see flows here, and these are basically data pipelines that we written in Python. And the reason of this is because now the system of record is a remote cloud company, right? So we have to write code to be able to call APIs, download the data, and move it into the data lake. So we're gonna have to create a data pipeline with code. And Python is very powerful for this stuff. It's very friendly, very powerful. So what we can do here is just basically, as I show you here, we only had the data from January or so, right? So he can just go ahead and run this Python file here, which is here, and say, hey, download the data for the month of February, for example. And you can run it. You can actually run it from here, and we won't wait to finish because it's gonna take some time. But what it does basically is gonna be running this Python file, and it's going to say, go get this information, these files, and it's going to execute basically a data pipeline to be able to start downloading data. And what it's doing is basically going and searching and saying, hey, what data is available for this? And it's just getting that data, right? And it's just loading and reading. And what it's actually doing is moving it, downloading it, and moving it into the data warehouse. So eventually, as this is running, our data lake. As we refresh our data lake, that we only had this files, eventually once it gets there, we'll see this growing. So now you see we went from 4 to 7 files, right? And so on. So this is now we're uploading data here. So now our external table has even more information that is available. Okay. All right, sorry for the flickering, but that's basically what this is doing, right? So now if we run our data lake again, we can actually see, hey, we got more files now. So that's just to illustrate, and the code is a lot more, right? I won't go into the code, but you can open the file, you can read it, and it shows you how to build flows, how to build tasks, how to also basically how to do tracking, right? Tracking of the task. For example, we can do metadata here to be able to say, hey, with this flow, we can do the following. And what's going to happen is we decorate the functions in such a way that it enables us to write a lot of information, right? So we can write a lot of information, and when we look at the dashboards, we can pinpoint where things are falling off, where things are failing. All right, so now our data flow is sort of working, and basically what we need to do now is how do we interact with BigQuery? I show you quickly, right, with Gemini how to build a query. Not too fancy, just something simple, but it can get complicated based on your data structure. But I want to show you that you can use a code-centric approach and basically query BigQuery from Python. So you can actually write Python code here, be able to say, hey, let's query the external table. So I could just write a query like I did on BigQuery and say, hey, give me all the data from my external table, and executes. And then basically this is gonna go get that data that's there, right? And of course, the important thing here is that you can just now do more complex data analysis and be able to start saying, what are my dimensions? Where are my fact tables, and so on, right? So this is the whole purpose of querying the external table, is to give you all that information. But eventually you come out with a design, right? You come up with your logical data models, and you're able to now move into the analytical phase of this. So how do we do that? How do we arrive from that raw data into our logical data model? So you basically look at there's a data modeling Jupyter notebook file, and what that's going to show you here is our lineage, right? So this is basically what this means is, how do we arrive now our dimensions and our fact tables from a raw file, right? From raw data. So if you remember, we have this external table, right? So we have this external table, and it's raw data, and from there we arrive into what's called a station, which is a logical model for stations. And we have booth, right? And what we're doing is we basically grabbing the raw data, taking out what we think is a dimension, building the staging version of that, which is the logic model. And from there, we can materialize that into actual physical tables, which is now basically what we're going to be able to query. So what this lineage is showing here is that from the raw data, we come up with station logical model that gets materialized into a dimension table, and eventually we build our fact table based on the join between the station, the booth, and the raw data, the raw transaction. The transaction is so many commuters landed this station on this day on this hour, basically, and that will be the transaction. So what we do there, we basically can now build our model. So basically here, this query that's here, and this can also be executed from BigQuery. But basically, what this does, if I run this just goes and it starts going, okay, let me just build out my model, right? So this is just going through Python code and saying, okay, let me look at the dimension at the logical models. Let me see what new data is available, and let me do execute an incremental update. And an incremental update, what that means is any new data not on my database, not on my data warehouse. If there is new data not in your tables, then this actually handles this, and it does a data merge, right? So in this case, we just execute and it did not find anything. But the process repeats itself for everything else, right? For all the other dimensions, we do tests, we do the fact tables, and so on. And we can basically do this with more time and understand the entire process. Okay. So yeah, so this is basically what I just talked about. Now, once we have these tables, we can do data analysis and basically come out with a dashboard that looks like. And that dashboard is also available on the GitHub repo. It's live, and you can look at data from, you can go back in time to a data range, and you'll see the dashboard. And basically, you'll be able to see everything that we have generated is actually displayed for the purpose of this. So if you look at the discovery phase, you'll see basically, let me see here really quick. You'll see how through the process of explaining all of this and arriving to that. So, right. So you will see here all the details. How do we cover this? It's based on this book, the person of what offense type solution, and how we arrive to the data analysis. And if you click on that link, it will take you to that report, and you can run it live. Okay, so you have to go back maybe to 24. I don't think I have new data in there yet. But the idea is that this is the end result, right? A geofencing type dashboard that enables people to see the activities of commuters day of the week, hour of the day, and so on. All right, so we reach our conclusion. Let me see. Javier, Gilberto, everyone, thank you. Thank you. We made it to the end of the presentation, and I know it's a Wednesday, half in the middle of the day, but everything that we cover here basically is based on this book. Please take a look at that GitHub repo, start that repo, scan that QR code, if you will. It gives you the links to other GitHub repos for AI, web development, and link for the book as well. So thank you everyone. I enjoy doing this presentation, so please follow the GDG chapter for additional presentations that we're doing. And thank you for your time, and have a great day. Thank you. Bye-bye.